Alright, so we're on to our Unit 3B notes here. On this number 1 here, what we're going to work on is both sets of problems 1 and 2, and 1 and 2. The left will be left for practice. So, distance formula, we can go ahead here and derive it. I'm just going to kind of focus on giving it to you guys at this point. It's another thing, it's a note card thing. So, in general, we got 2 points, x1, y1, and x2, y2. That's our distance formula. The key idea here is how we're typing it in. So, if we're finding the distance here, this is x1, y1, x2, y2. Now, what we're going to do is we're actually going to leave these in the form of the square root. The reason why we're doing that is just to make it a bit simpler when we're typing it into GeoGebra. So, here, my distance, d, square root, parentheses, x1. Whenever you have a negative, you have to put it in its own parentheses. So, in general, here's kind of our skeleton we're going to fill in. So let's go ahead and adjust this a bit here. So, that's the skeleton I'm going to go ahead and use for both these problems. I suggest you do this same thing. Now, if you use this skeleton, again, it's going to give you an opportunity. It's pretty unique. So, I'm going to fill these in blue. So, I have x1 minus x2. x1, negative 2, so in parentheses, negative 2, minus x2. So that's just 0. Doesn't need its own parentheses. y1 minus y2. y1's 5, minus y2 is 2. What you're going to type into GeoGebra, I'm going to do this one time, is everything except the square root. So I'm going to type all of this just how it looks. So give me a second here, and I will go ahead and show you guys that. So we have parentheses, parentheses, negative 2, minus, let's see what we have here. 0. Okay, I'm just going to write it out because my computer's being a bit buggy here. So, what we're going to type in, I'm just going to show you for the calculator part here. So, in GeoGebra, or in your calculator, just like that. So what I get, what GeoGebra is going to spit out here, would be, this is going to give you 13. So our distance, our final answer, we're just going to leave is the square root of 13. So again, what we type in the calculator GeoGebra, we'll leave the square root in our answer. Moving over here. So filling in x1 minus x2, this one's positive, so I can just leave it. y1 minus y2, it's a negative 1, so it gets its own parentheses. So here, in our GeoGebra, or calculator, and what we'll get is 50. So our answer here for the distance is the square root of 50. For homework, you'll be completing problems 3 and 4, as well as the 2 below. Here for our midpoint. So midpoint's kind of unique. It's the only thing I want to use to get an ordered pair. So let's go ahead and set up our work here. Okay, so for the midpoint, x1 plus x2. And again, let's stick with that anytime we have negatives, so let's go ahead and throw some parentheses around them. y1 plus y2. Type this in the calculator. So in GeoGebra, what you'll get here is -2. You are allowed to get decimals or fractions, they're totally fine. This one just happened to be a whole number. Here, you should get, when we type that in, 3. So our answer, -2, 3. Again, decimals, fractions, always cool as well. For here, x1 plus x2 over 2, y1 plus y2 over 2. GeoGebra gives us 1. GeoGebra here gives me 1. So, my answer, 1, 1. So for your homework now, you are completing this 3 and 4. Don't worry about the challenge, as well as this 3 and 4. Once you have done so, we're going to go ahead and move on. Notice the number 2 is not in here. My bad on that. So don't be confused. It's not supposed to be there. Okay, now we're going on to number 3 here. So we're looking at some transformations. So we're going to kind of skip through this first part here. Alright, so the first ones we're going to work on. We're going to kind of mess around here a little bit and just see what transformations can do. So for our first one here, what this means is I'm going to take my points and change them in this way. So we got a triangle, so let's look at these 3 corner points. So I'm going to label them A, which is at the coordinates of 0, 0. B, which is at 0, 4. And C, which is at 3, 0. So let's just copy those down over here. Alright, now, what it's telling me is, to my x values, or my first ones, I'm going to minus 2, and to my y's, I'm going to add 4. So here it's 0 minus 2, 0 minus 2, and 3 minus 2. To my y's, I'm adding 4, so it would be 0 plus 4, 4 plus 4, and 0 plus 4. 0 minus 2, -2, 0 plus 4 is 4. So that would be A prime. That little dash just means prime, means after we transformed or moved something. So then B prime, 0 minus 2, 4 plus 4. C prime, 3 minus 1, 0 plus 4. So if I want to plot this in red, -2, -4 would be somewhere down here. Oh, that should be positive 4. So -2, positive 4. B prime, -2, positive 8. It should also be down here. I counted wrong. And then C, 1, 4. So my new triangle just got moved around a little bit. This is what's known as a translation. So the object was basically just slid, or he performed a slide on it, so it moved it over. Alright, taking a look at this one. let's get our points first. So let's look at our A, B, and C again. So A is 0, 0. Just gonna write that up here. B, 0, 4. And C, 3, 0. Now in this one, it looks like I'm switching, and I'm going to make the x negative. So my first number becomes my second number. It goes negative, second number becomes the first number. So okay, let's do this one in two parts. So first I'm going to flip-flop them. So A, flipping, well, it's still 0, 0. B, flipping. And C, flipping. Now it's telling me to make that second thing negative. Well, 0 is still just 0. Negative 0 is still just 0. But here, this becomes a negative 3. So these are going to be my A prime, B prime, and C prime. So A prime, same spot, didn't move. B prime, looks like it's moving. Oh, it's actually going to go over here, so it's like spinning. And C prime. So here is my new triangle. Now, since we noticed that it's rotating, this is what's known as a rotation. Or you could think of it as spinning around. Looking at number 3. Alright, so it looks like the order is the same, but now I'm doing a little bit of algebra. I'm multiplying and I'm going to add here. So let's get our points. Alright, so I'm multiplying each of my x's by 2. So and I'm adding 1 to each of my y's. So that gives me my new letters here. 2 times 0 is 0. 0 plus 1 is 1. 2 times 0 is 0. 4 plus 1 is 5. 2 times 3 is 6. 0 plus 1 is 1. So if we go ahead and plot those new points. Here is our new triangle. So this one, it got bigger. So that's what's known as a dilation. Anytime we're multiplying, we get a dilation. Also, kind of move things around a bit. So this is a dilation because it got bigger, because we multiplied. And then I added. So this is a dilation and translation. What I want you guys to do now is go ahead and complete both of these problems in our exit pass, as well as go on to 4. Here, you're working on all 6 of these problems. Once you've completed that, we can go ahead and move on to 5. Alright, so 5 deals with the concept of rigid motion. We're going to kind of burn through this one, and you'll understand why. Here's the big idea. I can add to x and or y. That's cool. It's still rigid motion. I can multiply to x and or y by -1. Still rigid motion. If you multiply by anything besides -1, it's not rigid motion. So, with that, let's go ahead and take a look here. Well, this one, that's definitely different sizes. Not rigid motion. Here, adding and subtracting, we're all good. It's rigid motion. Rigid motion just means you're not dilating this. So rigid motion means you didn't do a dilation. Uh-oh, I'm multiplying by something that's not 1. Not rigid motion. Multiplying by not 1. Not rigid motion. And it looks like I forgot to copy in a few problems, so let's not worry about those. With that, we've completed notes 5. For 6, work on going ahead and plotting these as well, and then you're going to tell me is it rigid motion or not. From here, we are on to 7. Alright, so we're on number 7 for our notes. This is going to deal with translations. So essentially, our big one here, this is our slide, right? So this is where we're adding or subtracting to the y's and the x's. Okay, so I'm going to go right 1, up 4. Well, that means for every point x, y, I'm going to translate it. Right 1, that means I'm going to add 1. And then up 4, I'm going to add 4 to my y's too. So you're up and down, or let's say x. X deals with left or right. Now y, up or down. So we already got our coordinates filled in here, so I'm going to add 1 to my x's and add 4 to my y's. So we go ahead and plot these points. And we get our new translated triangle. We already did this part here, right in the rule. Alright, let's go ahead. Trying to think how quick I can make it for you guys. Alright, let's do 2 more examples. Okay. So let's draw this triangle. J, 0, 2. K, 3, 4. And L, 5, 1. Now, translation 4 to the left. So that means it's like x minus 4. 5 up, y plus 5. So we're going to minus 4 from each x, and add 5 to each y. So plotting our points. And we got our translation. And we wrote our rule already. Alright, here's working a little backwards. So, to get the rule, let's think about how we're moving. So let's look at one. Let's look at n and n prime. It looks like I'm moving to the right to get to n prime here by going 1, 2, 3, 4, 5, 6 spaces. So that's right, so it's plus 6. Then I'm going up 1, 2 to get to that point. So that'd be y plus 2. Had we moved down and left, they'd both be subtracted. From here, we should be good to go. What I want you guys to go ahead and do now is jump onto 8. And let's do numbers 2, 3, 4, and 5, 6, don't worry about that, 7, yeah, let's go ahead and do it, but chances are you already would have done it. And let's not worry about these. Once you're good through there, you're set on the practice for number 8, and we're going to go ahead and move on to notes 9. Alright, so taking a look at notes 9 here. Now we're dealing with reflections. Okay. A reflection is a transformation. I want to think of this as kind of flipping the figure over a line of reflection. Really unique name. So, we're just going to think about that. Alright, so we got ABC is reflected over the x-axis. So here it's telling us the x-axis, so this line is our line of reflection. So we're flipping over it. We're going up. Now, let's start off with our points here. So A is at the point 1, -3. B is at 3, 0. And C is at 4, -2. Now before we write the coordinates, we're going to go ahead and see what this would do. So if I flip it over the line, let's see, it's 1, 2, it's 3 from the line. So instead of going down 3, I'm going to go up 1, 2, 3. So that new point is at 1, +3. B, well, it's on the line, so it's a distance of 0, which means it's going to stay there when I make a new one. So B is still at 3, 0. C, well, it's a distance of 1, 2, so it's going to go up 1, 2. And I get my new triangle. So those coordinates will be 4, +2. So a general rule for this one, looks like all my x's stayed the same. My y's, they just turned from negative to positive, so that means multiply, or change the sign. So we write that as -1. Is it similar, congruent? That means, is it rigid motion? Yeah, because I'm not multiplying by anything except -1. Example 2 we're going to skip, because you can see it didn't copy and paste very well. But if you wanted this general rule, trust me at this point, it'd be -x, +1. So kind of the opposite of what we've seen up here. These would be great things to maybe throw on a note card when I was taking this test. Okay. These ones shouldn't be too bad for us. So let's go ahead and try example 4. Alright, so I'm going to start off making this one in black so it's easier for us to see. So A is at 0, 1. B is at 3, 4. And C is at 5, 1. Now, we're going over the line. X is equal to -1. So let's make this purple just so it's easy to see. So x equals some number. That's a vertical line. They go up and down. If I had y equals some number, that's a horizontal line. They go left and right. So it's a vertical line through -1. So here would be my line of reflection. We'll also go ahead here and do example 5. And that should tie up these notes pretty nicely here. Alright, so let's think about what this is going to do. So I'm going the same distance in the opposite direction. So let's make these red. So A looks like it's 1 from the line. So now I'm going to go the opposite way. 1 from the line. B is 1, 2, 3, 4 from the line in this direction. So I'm going to go 1, 2, 3, 4 this way. C is 1, 2, 3, 4, 5, 6. So let's go 1, 2, 3, 4, 5, 6 this way. So thinking about these points, A is at -2, +1. Here, B prime is at -5, +4. And C is at -7, +1. So you'll notice those general rules only work with the x and y axis. Otherwise, counting's our best bet. Okay, for our last example for this set of notes, let's go ahead and plot our triangle again. And this time we're going over y is equal to -2. So that's a horizontal line. So -2 horizontal line. So let's see, we're 1, 2, 3 away. So 1, 2, 3. It's going to be my new A. B is 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. C is 1, 2, 3. So 1, 2, 3. So our coordinates, A is now at 0, so -5. B is now at 3, -8. And C looks like it's at 5, comma, -5. Drawing the line of reflection here just means find the middle between those 2 points. So that would be the y-axis. Here, well, the middle of, let's say, A and A. So 1, 2, 3, 4, so that'd be 2 would be the middle. And this equation would be y is equal to -1. And we go and skip over these. Once you've completed notes 9, I want you to go on to practice here, number 10. Let's do these problems. There. Here. No. There we go. This one would work, so I'm looking for either x equals a number or y equals a number. You pick which one is correct, judging by if it's going to be a vertical or a horizontal line. Don't worry about 6. Or that. So, You're working on practice 10 now, and then we'll go ahead and move on to our notes in 11. Okay, so on 11 here for our notes, we're looking at dilations. Alright, so kind of how to find what's called a scale factor. It's what we're multiplying by, and hint, it's not 1 or negative 1. Dilation is going to give us that non-rigid motion. Okay, so F here in our rule is the scale factor. So to find this thing, we're going to do what we start with is known as the pre-image. What we end with is the image. So think about taking a picture. So if it was 3, the rule would be x comma y goes to 3x comma 3y. So we're just plugging in that scale factor for F. Alright, let's take a look here. So we have the A, B, C with these given vertices. Scale factor, or an F, of 4. So what that means is my xy is going to go to 4x comma 4y. So if I multiply 4 to both numbers in each of these points, that would give me 4 times 0, 0. 4 times 2 is 8. 4 times 4 is 16. That's for both. Here, 4 times negative 1, negative 4. And 4 times 4 is 16. Alright. Quadrilateral PQRS has those points dilated by a scale factor of 1/2. So our rule here is for every x comma y, we get 1/2 x comma 1/2 y. Alright, so let's do some work to the side here. So for each of these, we're going to multiply it by 1/2. So I'm going to throw that in blue, and I'm going to keep my original stuff red. So my original points here are negative 2, 4, 4. And negative 4. So here, you might be writing this work up a little differently. I just want you to see where I'm multiplying those 1/2s real clearly here. My original y values, 4, 4, negative 2, and negative 4. So my new ones here, so I'm just multiplying these again. Rock some GeoGebra here. Here you might get fractions sometimes or decimals. Still fine, as long as you're showing the work and you're doing the problem correctly. Alright, so let's go ahead and plot our original here in some red. Okay, so I have P, negative 2, 4, Q, 4, 4, R, 4, negative 2, and S, negative 4, negative 4. Then my blue here is going to represent that new one we found. So, negative 1, 2, 2, 2, 2, negative 1, and negative 2, negative 2. So this is what our dilation would look like. So since we multiplied by something less than 1, we've seen it just got smaller. And we're going to skip over kids here. So here, if it's less than 1, that means it's going to get smaller. If it's more than 1, it's going to get bigger. So since 5 over 2 is greater than 1, this one's going to be an enlargement. It's going to get bigger. If it was less than 1, like 1/2 above, it'd be a reduction. Alright, so let's think about this. We're going to take what we have, and we're going to find the scale factor. So let's think about A. A is at 0,6, whereas our A prime is at, oh I lied, 6,0. This one's at 2,0. So we've seen our 0 didn't change, so that's really not going to give us an indicator. But if I think about how my next one changed, so the formula here to find a scale factor, or F, we're going to take our pre-image, so that's just our A, and divide it by our image, A prime. So looking at those x's, that would be right here. I wrote that formula upside down. My bad, guys. It'd be A prime, so our image, divided by our pre-image. So in this case, A. So it'd be A prime divided by A, which is 2 over 6, which gives me 1/3, or you could get 0.33. Either one of those answers is fine by me. So here, our rule for this one would just be x comma y. Scale factor of 2, multiply your x's by 2, multiply those y's by 2. So for our points here, let's see, x is at -1, -1, 2 is at 1, 1, and y is at -1, 2. So go ahead, multiply there, you're good to go. Don't worry so much about this. Alright, so once we're through there, let's go ahead and check out 12, which is going to be a section of practice for you guys. So here, let's check out these problems. Don't worry about that one. Yes. Notice these are multiple choice. So go ahead and do the work, pick the right answer. Let's go ahead and do that one. Again, a multiple choice option. Yes. Don't worry about 7. And let's go ahead and do 8. And don't worry about 8. So, those are your practice problems there for 12. Alright, finishing up our notes here pretty soon. We're looking at 13 now. So looking for our rules here on rotation. You guys are going to love this. It's a short one. Skip it. Skip. Also skip. Boom. These rules, 100%. Write down on a notepad. So, we're starting with these points. Now notice my red is under the direction of clockwise. That means we're going the same way as a clock, so kind of rotating around. So we're going this way. Counterclockwise is that one, so opposite of a clock would be our red. So again, my apologies, I kind of crossed that up. So counterclockwise, here's my clock. Right? Counterclockwise means I'm going the opposite way. Clockwise means I'm going the same way as a clock. These are literally just rules. So starting with XY, here's my counterclockwise, it's my reds. Clockwise are my blues. So, copy those down and label them accordingly. After that, let's think here. Okay, so 3, 2, 90 degrees, counterclock. Okay, so I switch the order, make the first one negative. So let's switch the order first. And then my first point switches the sign. So it becomes positive 2, 3 stays the same. 180 degrees, well, let's see, counterclockwise, 180. The order stays the same, I just switched the signs. So negative becomes positive, positive becomes negative. 90 degrees clockwise, look at the blue. Switch the order, so my x and y turns to yx. The second thing becomes negative. So let's flip the order. Second thing becomes opposite sign. Rotations are very easy, and I do not expect you to memorize these rules, so just know how to use them. That's going to be it for the notes on this section. So in your practice, go ahead and use those rules and the same skills we've used. 2, let's see what problems we want to do here. We're going to definitely do 1. 2 as well. Ignore the part that says about the origin. Every rotation we do is going to be about the origin. Let's go do 3. And notice this is definitely crossed out here. So get rid of the and then reflecting part. And just do 4 as it says. Not 5. Let's go ahead and do 6. And again, these are crossed out. Not 7, not 8. Or 9 or 10. So, do the problems we circled. And then at that point, you are done with your practice problems for 14, and you're ready to move on to notes 15. Alright, kind of going over our last section here. So, this is going to be what's known as a composition of transformations. So we're going to work through problems 1 and 2 together. And then your job is going to be to complete 3 and 4. And at this point, I'm sure your guys' hands are killing you. So let's make a little adjustment here. We'll do problem 1 together, and then all you have to do for the practice is just problem 4. I'll leave 3 through 5 as optional. Again, I would suggest doing them all, but all that I'm going to check off for your work completed is problem 2. Okay. So, composition transformations basically means we're going to do more than one thing. Let's zoom in a bit here. First thing I'm going to do is I'm going to make my pre-image here. I'm going to write it in black. So C is at -6, +8. D, -4, +2. And E, -2, +6. Alright, now let's get some red going on. So for our first step here, we're going to translate the figure according to this rule. So, for all my x's, I'm subtracting 1. For all my y's, I'm going to add 3. So, what that gives me, here's C, D, and E. So, my reds, C prime, notice it just got 1 prime, D prime, E prime. -7, 11, -5, 5, and -3, 9. So I'm going to go ahead and plot those points now. Again, take your time with this. Like here, my C prime is a little off my graph. That's fine. Just have it be close. Alright. Now we're reflecting over the x-axis. So I'm going to do this one in blue. So first, let's go ahead and copy down our kind of originals here. So that above output we had, right here, was C prime, D prime, E prime. And my points were negative 7, 11, negative 5, 5, and negative 3, 9. Now again, we did reflections. We talked about that whole concept of drawing a line and counting. So here I'm looking at the x-axis. So the x-axis is here. So let's go ahead and highlight that. Then I can just count from my red shape to get my new points. So we're looking for C double prime, D double prime, and E double prime. And it's a double prime because this is the second transformation I'm performing. So let's take a look at C. Well, C is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 up. So I'm going to go on that same line that it's on right here and go down 11. So that's C double prime. Its coordinates are negative 7, negative 11. D looks like it's 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. D double prime. Its coordinates negative 7, negative 7. Also, totally counted wrong there. Those are definitely 5s. So, my bad there. But again, the distance should have been, let's see here, 1, 2, 3, 4, 5. So I'm going down 1, 2, 3, 4, 5. Don't know why I called those 7s. Alright, looking at E. We are 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. Quick check. Did I look at the right point? No, I did not. We want that red triangle. So, we're actually 1, 2, 3, 4, 5, 6, 7, 8, 9 from the line. So, going off that one, 1, 2, 3, 4, 5, 6, 7, 8, 9. So, E double prime. So E is at negative 3, negative 9. Alright. And for our last one, let's use green. We're going to rotate 90 degrees counterclockwise about the origin. So let's copy down these here. So basically, the only difference with compositions is we got a little more work to do. But, as far as the work goes, it's the same thing. Just like doing a multi-step problem. So let's take a quick glance back here, because I didn't expect you guys to memorize these. We want counterclockwise 90 degrees. Counterclockwise is red, 90 degrees. So, flip the order. First thing turns negative. So flip the order and the first thing turns negative. So okay. And that turns negative means we're going to switch that sign on. So C triple prime, because it's our third one we're executing. Okay, so let's flip-flop, flip the sign. So negative 11 goes first, and I'm changing the sign to positive. Negative 5 goes first, make it positive. Negative 9 goes first, make it positive. And if had they been positive in the first place, then we'd be making them negative. From here, let's plot this last triangle. C triple prime, 11, so we're somewhere out here, negative 7. D triple prime, 5, negative 5. And E, 9, negative 3. So our final triangle is the green. Once you've completed this problem, please go ahead and try 2. And again, I highly suggest you also complete sum of 3, 4, and 5. However, again, all you're going to check in with me is number 2. Once you've completed this, I would like you to go on to the review. You are working through all of these problems. Also, notice these subpages. Each one of these represents a single page of the review. You are completing those as well. Once you've completed that, your final assignment for Unit 3B is to pass the Unit 3B exam. Good luck.